Okay. All right, so we're going to get back into our research method notes. So I'm going to pull those up for us. Going to review some of the last things we did last class, which were the 3 types of descriptive studies. I won't review all the old stuff because we've kind of talked about it a lot. So like I said, it looks like, you know, this is all the stuff from Unit 1. We've talked about the study guide. You're currently doing the reading guide while you're reading. Yes, you can type that. Normally I say you can't, but since we're doing everything on the computer, that's okay. We've done the what is psychology slides. We did the what a psychological approaches chart, and we took our quiz. So, and we'll probably go over the quizzes next class. I won't do it on the recording, but you've seen the grade in there. They've all been graded. And if you have a question on something, let me know, but we'll go over them. It'll be weirder because it's not in person, so I can't like hand you a piece of paper and you see what you missed and I say the answer. So you might have to kind of like look at what you did, that type thing. So we're in research method slides. We still got to do the research methods activity, and then all you have left to turn in is your book and your vocab, like your reading and your vocab. But we are not quite as far toward the end as I thought because I forgot how much information was in the research method slides. We're about only a third of the way through it. Even though it may look like we're a little further because like if you look at the sections, like we're about to go into correlations, but these last sections are bigger. And so where we kind of flew through some of these, it's going to take a long time on some of these. So, you know, if you look at the numbers, now granted, I know it looks like a lot, but some of them are like practice slides. Yeah, there's like 70 slides. And I think we're around like slide 20 or something like that. We still got a ways to go. So I'm thinking probably after today, seeing how far we get next week, I should be able to let you know when you come to class what our plan is for finishing or working on that last worksheet for when the test will be. And on test day, that's the last day of the unit, and that's when your reading will be due, and that's when your vocab will be due. So keep that in mind too. All right, so let me scoot through these back to where we were with like descriptive studies. I should have done that because this takes forever. And let me know what office they were running for. Sorry. If you're a senior, you can turn in your forms to run. This is dumb. Let me get out of here. It's taking forever. If you're a senior, you can turn in your forms to run for an office. It's due today. Just turn them into me. If you turn them into Ms. Carmichael, she's just sending them to me. So like Alan, I think you're on here. She's sending it to me. Because I think you sent it to her. So if you are a senior, go to the Senior Bobcats, www.seniorbobcats.com, and get that to me today because I'll be checking eligibility and making our stuff for campaigning next week. Oh no. Wow, I thought I was where I needed to be. I didn't. Can you tell it's a Friday? All right, here we are, correlation. So part 4 of your notes, if you're keeping them in order, this is a new section. Correlational studies or correlations. I bet I hadn't even hit shared screen through all this, have I? Nobody was going to tell me I wasn't even sharing my screen. I was just talking to myself crazy. All right, I should have started the recording now. For those watching, I'm sorry the first couple minutes were a waste. Now let's start. All right, so part 4, correlational studies or correlations. I'll give you a second to write that. All right, so correlations show like a relationship, but they don't show cause and effect, which is like, I can guarantee you that's going to be on your final exam. It's like their biggest, like, not trick or catch, but it's like one of the biggest things they know. Because people want to say that because this happened, then this happened, and that's true, but that's in an experiment. That's in the next section of notes. It's not a correlation. So like my favorite thing, and I think I have a picture of it, it'd be like if somebody was walking in late with like a Starbucks, you know, you would say they, you know, the Starbucks is what caused them to be late. And they could be like, remember, correlation is not causation. That Starbucks didn't cause me to be late, which is true. They could have went to Starbucks early, got in bad traffic between Starbucks and, you know, coming to school or something, and then they were late. So it doesn't mean it causes it, even though we all want to sit there and be like, nah, you're late because you went to Starbucks, you know, that type of thing. So what a correlation does is it describes behavior and it attempts to predict it, and it shows a relationship, but it can't show like the cause and effect like you think. So here's the definition of a correlation to write down. It's the measure of the extent to which two factors vary together, and thus how well either factor predicts the other. Thank you. It was a little loud. I appreciate it. But I want you to tell you. Well, thank you. You want to say hi? What? Those are all my students, but you can't really see them because they all turn their camera off because I'm recording. So you can say hey to everyone. They'll see you, I promise. All right, I'll be done in a minute, okay? All right. So the way we measure a correlation is we use something called a correlational coefficient, okay? And it's just a number. So it's a statistical index of the relationship. That's their fancy definition. AKA, it's a number value we assign, you know, between two, and it is a relationship between two things. And it varies from -1 to +1. Because I need them to hear me. So I know that might not make a lot of sense right now, but I promise in a second it will. Knowing this number is really important because you know how strongly two things correlate. If you have the closer to the +1 or the closer to the -1, the closer you get to the number 1, whether it's positive or negative, that is a stronger correlation. -1 is just as good as +1, okay? So don't think like +1's perfect, -1's like the worst. It's not. 0 is actually the worst. And so 0 is no relationship. And then you can have it that much this way or that much this way, like +1 or -1. So the closer your number is, your result is to a whole number, the stronger the things correlate, the stronger the relationship they have, the more they go together. The closer your number is, like your result in something, to 0, then the less they correlate, the less they actually have a relationship, and the less they go together. So knowing how much, oh, sorry, I moved the thing. There's like a bar over it. I can't read it. Knowing how much, I don't know what that says because there's a bar over it. Hold on, guys. Y'all could tell me. Knowing how much, oh, aptitude. I could not figure out what that word was. Knowing how much aptitude test scores correlate with school success shows us how well the school, knowing how much your aptitude test score, the value, the result, correlates with how much your success is in school, like your grades or whatever, shows us how well that score actually predicts. So what that means, okay, an aptitude test is like the SAT. So if you do really well on the SAT and you have really good grades, then that's probably like close to a +1 correlation. And that shows us, yes, the SAT does predict someone's grades. There is a strong relationship between how well you do on the SAT and how well you do in school. Now, we all know there's people that don't do well in school. They're lazy, but they're not stupid. So they may rock out on the SAT, have terrible grades in school. That's not a correlation at all. But we take all the SAT scores that everyone takes across the country today. That's not that common. What is more common is that test does correlate. If it didn't, no one would use it. The ACT is the same way. So basically what they're saying is most of the time, the better someone does on the ACT or the SAT, the better their grades are. And most of the time, the worse someone does on the ACT or SAT, the worse their grades are. And there does tend to be a pretty strong correlation between the aptitude test score and your school success. And so that's why colleges use it, because they don't know who you are coming in, and they want to know, are you going to be good? Like, are you worth our time to let you into our college? And so they look at that test score and they're like, oh, a high score, they're probably going to do well, let's let them in. Or a low score, they might not do well, don't let them in. And again, that's not all the case. We know people who are super smart but get test anxiety, so maybe they bomb. That's why there's other factors they consider too. It's not the be all end all. We know there's people who are super smart, but then they, they have bad grades, and that's where the college be like, cool, you rocked out on the ACT or the SAT, and they'd be like, whoa, you don't pass your classes. No, we don't want you. That type of thing. So that is something that, yes, correlates. There's several things in life that correlate. And it, like I said, if it didn't correlate, colleges wouldn't use it. So you may love the ACT, SAT, you may hate them. You may think they're the best thing ever, you may think they're the stupidest thing ever. But statistically speaking, there's value in it, for sure, and that's why they use it. All right, then you have something called a variable, which is anything that can vary and is feasible and ethical to measure and to study. Those of you who are seniors, hopefully you're signed up for the Senior Remind. I'm getting blown up. Miss McCormick told me to share that picture about how Senior Picture Day is coming up, and everybody's like, how do I sign up? How do I sign up? How do I sign up? And I was like, I don't know. I'm not the yearbook person. I'm like, didn't I say more information to come? So you're about, if you're a senior, about to get another remind, being like, I don't know how to sign up. Quit asking me. And if you're a senior watching this video, go make sure you're signed up for Senior Remind. We can eat lunch wherever you want. All right. So a variable or two variables can have a positive correlation, a negative correlation, or no correlation. So a positive correlation is what I just told you. SAT and school success, they positively correlate because they move in the same direction. So what that means is this: as the SAT score goes up, generally the school success and the grades go up. As the SAT score goes down, generally that correlates to the grades and the school success going down. So since they move in the same direction together, that's positive. That's a positive correlation. It would be like a +1. No correlation is when they move in opposite directions. So an example of no correlation would be the taller you are, or no. Erase what I just said. No correlations when they move all over the place. Sometimes up, sometimes down. They're all over the place. So a no correlation, a 0, would be like height and intelligence. Because there's some tall people that are smart. There's some tall people that are dumb. There is no correlation there. There's some tall people who are medium. Or if you're like short people, shortness and intelligence, like that, that's no correlation. That's a 0. Because sometimes it's moving together, sometimes it's not. It's all over the place. A negative correlation is the -1. And like I said, it's just as good as +1. So a negative correlation are when they move in opposite directions, okay? So an example is like as age increases, mobility decreases. You know what I'm saying? Like you can't run as fast, you're not as flexible, or you can't, get up off the floor anymore. If you're an old lady, you're like, oh, like whatever it is. Like, your body's strength and mobility decreases as your age increases. And that is a negative correlation, but it is true and it is good, because that is true that the older you get, the less mobile, the less you can do. Like right now, you guys can like run a mile. You can put your leg behind your head. You can do like all this kind of crazy stuff that, when you get older, as you get older, you're gonna be able to do less of that stuff, less of that stuff, less of that stuff. When you're an old lady or old man, you can be able to do any of that stuff. So that would be a negative correlation, -1. But that's just as true, that's just as good of a result as +1. Does that make sense? I'll stop here. Is there anybody with any questions about that? Because I know that some of you guys may have already known all this stuff from math classes, but probably a lot of you guys, this is new. And I want to make sure you're good. Okay. Sorry. Then everyone was still sending me messages about that. All right. So the way we plot these, the way we figure out is it negative or positive, we have to make a graph, so to speak. Okay, so we make a scatter plot, which are the types of graphs you've done. You know, you can do them now, but you definitely did them in like elementary school. Like, let's all go plot our point. We were this and this, and put the dot, and he was this and this, and he puts his dot, and that type of thing. So a scatter plot is a graph of cluster dots, each of which represents the value of the two variables, the one that's on the y-axis and the one that's on the x-axis, like your age and your mobility, and you put the dot, or your SAT score and your school success, and you put the dot. So you'll see some scatter plots here in a second. The slope of the dots. So if the dots are like here, don't write anything down. Let me show you some pictures real fast. I think I have a picture of them. Okay. So the slope of the dots is what kind of tells you what's going on. So this right here is no correlation. This is 0. Like I said, this is height and intelligence, because there's some, you know, really tall people who, if like height's right here on the y-axis and intelligence is down here and, you know, it's increasing, there's some really tall people who are really dumb. And then there would be some really short people who are really smart. You see what I'm saying? It's all over the place. Okay, so that's a 0. But the slope, like how much, that's what you can see in this picture, tells you the strength. So if the slope is like tighter together, that's stronger. If the slope is like loose, that's weaker. So that's a strong positive. And don't worry if you're not drawing them yet. I'll bring the slide up in a second. You can draw. That's weak. That's a strong negative because it's going down, and that's a weak negative. I guess they did like moderate on there too. But either way, if it goes up, so this would be like in SAT scores, right? So with the SAT, let's say your SAT scores are on the y-axis, your grades are on this. So this high of an SAT score, well, only this high of grades. But this high of an SAT score will look this high of grades, you know, like it's a perfect SAT score and like they have all A's. That would be that. And so like I was saying, you know, with old age and mobility, right? Like, you know, the older you are, if age is right here, and then here's your mobility. So you see the people, the people who have the mobility, they're down here, they're younger. And the people who like don't have the mobility, they're up here, they're older. So I just want to kind of show you what I was talking about before you wrote down some more stuff. If you didn't get those drawn, just hold on. I promise we'll come right back to it. So the slope of the points on the scatter plot represents the value of the two variables. And the amount, it's the recording thing's in the way and I can't read it. Sorry, guys. The amount of scatter. See, it's always weird words. Why is graphed red? Is that not right? Graph cluster. Yeah, I guess I don't need an ED. The amount of scatter suggests the strength. So the more scattered they are, that's looser, that's not as strong. The tighter they are, the less scattered they are, the tighter they are, that's stronger. That's closer to the perfect one or closer to the perfect negative one. So I'll let you write down those if you need it. When I told y'all you could take your cameras off, I now can't see when you're still writing. So y'all still need a minute?
Yes, please.
Do what?
Oh, I just said yes, please.
Oh,
Nobody answered, so.
you're good. Thank you.
No problem.
So once you get it, it kind of clicks and it's not like that confusing, but if you've never really been taught this before, it takes just a second to make it like click. So if something causes it, no, there's no causation. If something is related to it, they'll be together, either both going up at the same time or both going down at the same time, right? Or moving in opposite directions at the same amount or speed, not like, you know, like moving together. And that would show a correlation. These are the things you're going to practice on your research methods review. Don't start that yet if you have, you know, because I want to do it all together. It's kind of like a review before your test. And you probably have it in your packets. I'm up at school all day today, Friday. If you need a book or a packet, send me a remind, let me know. Jenny, am I good to go? Okay. Tell me if I'm not. All right, so a positive correlation is a relationship in which variables move in the same direction. So for example, increasing or decreasing together. When graphed, it makes the line go up. And that would be the value of 0.01 all the way to perfect, which is just a whole number 1. And if something was perfectly positive, it would be the 1. A negative correlation is when the variables move in opposite directions. So for example, one goes up while the other goes down. One goes down while the other one goes up. And again, they're just as good. Remember, it's just as like good of a result, if you will. And when graphed, it makes a line that goes down. So a negative correlational coefficient is like -1 all the way to just -0.1. And if you wanted something perfect, it'd be the whole number -1. So that's just kind of Can I go on, or y'all still writing? Am I good to go? If it's a no, tell me. All right, so here's the things I was just showing you. So write down the no correlation too. So no correlation shows no relationship. When graphed, it makes no type of line at all. Also, if you need to make yourself a note that the word negative, like a negative correlation, it doesn't mean bad. It doesn't mean like, you know, strength, bad direction. It means nothing like that. It just means opposite direction, where positive means the same direction. I'm not done yet. Why? What do you want to do? Okay, well, it's not even close to being lunchtime, baby. We will in a little bit. Okay. So take a second if you want to draw these in your notes. You don't necessarily have to draw it strong or weak. Just show positive, negative, no. Mm-mm. Mm-hmm. All right, so am I good to go?
Wait, let me take a picture.
Okay. No, you're good. You're good. Take your time. It's hard not seeing y'all, so I have no idea when you're done writing or not. So for the following correlation, I want you to practice this for a second. You can write it on scrap paper in your notes, whatever you want to do. I want you to think of something that would have a perfectly positive correlation. They definitely move in the same direction. Like I said, SAT scores and school success does move in the same direction, or colleges wouldn't use them. It's close to being perfectly correlated. Then 0.5 would be something that like generally moves in the same direction. Not always, or not always at the same speed or strength, but like generally. Then give me something that's like there's no relationship. Like I said, height and intelligence. Then something that generally moves in opposite directions, like as one of these increases, usually something kind of decreases. Again, not perfect together, just, you know, maybe not the same speed. And then give me a perfectly negative. So definitely when this goes up, this goes down, like every single time. So take a few minutes and see if you can come up with some on your own, and we'll either discuss them, or if y'all don't want to discuss them yourselves, I'll talk about some.
So you said like the SAT scores go like along with the grades?
That'd be like the positive one, because as the score goes up, the grades and school success goes up. As that score's lower, that person does worse in school.
Gotcha.
Yeah.
Thank you.
All right, so anybody got any examples that I didn't talk about that we want to share? Maybe they're even funny or something. Oh, no one wants to share? Surely someone won't mind talking.
So for zero correlation, I said, I guess if people like hot dogs, versus their ability to bake cakes. So, you know, no correlation there. And then I guess I said for 0.5, positive correlation, I said smoking and the risk for lung cancer. I mean, everyone, I guess, like who smokes doesn't get lung cancer, so I thought it was more of a 0.5.
There you go. Those are good. So yeah, like Katie said, zero would be like your like of hot dogs and your ability to make a cake. Some people love hot dogs, can't make a cake. Some people love hot dogs, best baker around. And then like she said, so 0.5, something that generally goes together, but it's not guaranteed, which she said would be like lung cancer and like smoking. There is a correlation. There are people, you know, there's an increased risk. I think we all know that to be true. And there's a great number of people who unfortunately get lung cancer and they smoked. But we all know people who have smoked who don't have lung cancer either. So you can't say it's like perfect. It's not so all over the place that it's zero, because there is a relationship there. But the relationship isn't 100% like if you have a cigarette, you will get lung cancer. So it's somewhere in the middle. That's good. All right, anybody got a negative 0.5 or a -1 that you want to share with us? Anyone? Let's see, I think I have examples on the next slide, so I'll have to think of them off the top. Yeah, I do. So like definitely like a 0.1, move together in the same direction. The more you age, the more you get wrinkles. I mean, my child, you know, that's 3, has 0 wrinkles. Her age is down here, her wrinkle level is down here. My grandmother, who's like 87, has a lot of wrinkles. And then when you're somewhere in the middle, like me in your 30s, you start getting some or whatever. So yeah, those are moving together in the same direction. So that'd be a 0.1. 0.5, move together somewhat. So like more violent video games, more violent acting. We have seen there's a relationship. We're actually going to talk about it in one of our studies with the Bobo doll. For those of you who've taken psychology, you're already aware of that study. But the more you watch violence, there's a link with aggression, and people tend to be more aggressive. Now, that's not to mean everyone that plays a violent video game is going to go out there and kill someone or beat someone up, but it's not like all over the place either. It's not a zero where there's no relationship because there is a relationship. Aggression does increase somewhat. So that's like somewhere in the middle of 0.5. 0 would be, like I said, eye color and intelligence. No relationship there. Negative 0.5, moving apart somewhat. This is what I was going to say. The more age and the less silly, right? So if I do your age and silliness, usually younger kids, you know, little age, are way more silly. And this is why it's on the negative, because they're moving in opposite directions. And usually older people, not so silly. But it's not everyone. You know what I'm saying? There's plenty of little kids who are not silly, and there's plenty of old people who are a hoot, right? But there is a relationship. Not like it's not like a scatter plot all over the place. Like, for the most part, younger kids do tend to be more silly. For the most part, older people do kind of tend to lose their like goofiness. So there is a correlation, there is a relationship. It's just not like every single old person, every single young person. And then -1, I got a bar through it, but I think it says move apart strongly. Does it say more age and less hair? Is that what that says, I think? Yeah, no, so I don't have to take my thing off. Y'all ain't gonna tell me what it says?
Yeah.
It does? Okay, good. I was like, don't make me end it. And I got a big bar through it, so I'm trying to like read and remember. So yeah, so, you know, the older you are, as your age increases, the amount of hair you have decreases. And I know there's plenty of people who don't lose their hair, but talking about people who lose their hair, you know, they start off as a little kid with a full, you know, as a 4-year-old with a full head of hair. And then, so, you know, as they get into their 30s, it starts thinning, and they get into their 60s. And then by the time they're 80 with the high age, they got no hairs left on their head. So I'd be talking about people who actually do, in fact, lose their hair. There would be nothing to graph if you never lost your hair. So that's a correlation. So you don't have to write those in your notes. You can if you want to take a picture of it or something. It's just a couple examples to think about. Hopefully you got some examples you wrote down in your notes too. You just want to share them with us. That's okay. So correlational coefficients, which are the numbers, they help us see the world more clearly because they tell us the extent to which two things relate. 0.66, is it 0.97, is it 0.12? Like, that's the number, that's the coefficient. And that's the importance of the coefficient because it lets us see the strength of that relationship, of that correlation. Correlations not only make visible the relationship we might otherwise miss, but they also restrain us from seeing things that are not there. You might want to say there's a relationship there because you think, you know, like I said, people who get Starbucks are late. But if you went out and mapped it out and this, that, and studied it, you may see there's no correlation at all. You know, sometimes people who get Starbucks are still really early to the meeting. Sometimes they walk in right on time. Sometimes 5 minutes late, but they're always going to be 5 minutes late, even if they didn't have the Starbucks. See what I'm saying? So sometimes you might want to see something, but then if you do the research and you get your values, you get your numbers, your results in the end, you're like, there's no relationship. So that's a helpful part of correlations too. There's this term called regression toward the mean, which is our tendency for extreme or unusual scores or events to fall back toward the average. There's always going to be outliers. Like I was telling you in yesterday or the day before's notes, like when I was telling you things like with a case study, there's always going to be an outlier. Well, my Uncle Joe smokes 2 packs a day and he's, you know, doctor says he has the best lungs he's ever seen. Yeah, there's always going to be outliers because the world's not perfect, right? And so a lot of times when those things start to happen, we have like, there is like, those things are extreme and they're there, but we tend to, that's not the majority of things. And we tend to go back to where the majority is, which is the average, which is the mean. So that's what regression toward the mean is, if you can write down. Average results are way more typical than the extreme. Not to say the extreme's not out there, but don't base everything on the extreme because that was just one extreme. It's not all the other averages. So that's regression toward the mean. So average results are more common, there's more of them, all that kind of stuff, and we should remember that. All right, am I good to go from this page? Nice. My kid's running and putting her belly on my rolly chair and just going across the front of the classroom. She said she's not my little girl, she's my baby, my little baby. She is. All right, so more on correlations. When we believe there's a relationship between two things, we are likely to notice and recall instances that confirm it. That's a bias we have. Like I said, if I'm this person who holds meetings and I think every time somebody comes in with Starbucks, they're late, you know, and I want to see that, then I'm going to see that. And every time I see someone come in late and they have a drink in their hand, I'm like, see, told you, bingo, duh. And it's just going to continue to reaffirm it. But what about all those times when I walk in and somebody's already there and they're just sitting there sipping on a drink? Do I even notice that drink? Do I even make the connection in my head, put two and two together and say, whoa, that's disproving what you usually think, Miss Parnell, because that person's early, but they have a Starbucks drink. Like that kind of thing. When things prove what we want to see, we remember them and we like keep them in our head as a tally, and we got this list and we can recall it because that time and then when she did it and that happened, see, there has to be a correlation. But we forget or we don't even notice all the things when they don't confirm it. And again, we're not trying to mess stuff up. We're not trying to like mess up some research or, you know, be biased or anything. That's the thing. You only know what you know. And so if you're only looking at this and you're really focused on proving this to be correct, you're missing all of this. You know what I'm saying? So I'm going to miss every time I walk in and, you know, you're already sitting there and you always just happen to have a drink, but I don't even notice it because I don't see you walk in with it in your hand. You know, you're already set up, your stuff's there, you're at the meeting, your drink's there, and I don't even pick up on it. You know, that type of thing. So sometimes there's these things called illusionary correlations. You know what an illusion is? It's something that's not real. And so this would be like a not real correlation. Like my Starbucks thing, you know, trying to think that's real, that might not, you know, be anything. So an illusionary correlation is when you perceive a relationship where one does not really exist. It's really zero. It's really that scatter plot that's all over the place, but you swear there's a correlation. You swear there's a relationship, but like factually, statistically, if you researched it, there's not one. Or you perceive a relationship to be stronger than it really is. You think it's like a 1.0, where it's barely like a 0.33, something like that. So I'm going to show you one in a second that'll kind of blow your mind. Well, at least I think it will. So here's a couple first that aren't as crazy. So more accidents occur at home. That is a true statistic. More accidents do occur at someone's home. So are homes more dangerous? You might be led to make a correlation and be like, increased danger, increased accident. Homes are more dangerous. You know, they're just these like scary places or whatever. No, the reason why, and so the reason why is because we spend more time at home. You're more at home, you're at home, or most people are. Again, there's outliers that work crazy hours. Most people are at home more than they're anywhere else, added up total. So the odds are in your favor, you're going to get hurt more at home. So you could try and see a correlation. You could, you know, again, have your bias out there, have your blinders on and be like, oh, homes are more dangerous. You try and, you know, every time someone tells you something from a house, you're like, see, that was really dangerous. But you're missing the big point. You're missing everything that's out here, and you're trying to make a correlation where one really doesn't exist. And so if you like researched it out, you would find they're not more dangerous. But then if you researched it out with time, you would find increased level of time spent at the house, increased amount of accidents. Well, that's why. There are more car accidents. Car accidents happen more commonly within a 2-mile radius of your house, which is pretty close to your house. So are you a terrible driver when you think you're almost home, you're 2 miles from home, and you're just like, screw it, you know, I'm gonna just drive like whatever. No, people don't do that. But you always, and I always put this up on the board if I'm here, like, here's your house, right? Here's the 2-mile radius. You know, the radius is like out of the circle, right? So here's the circle, the 2-mile radius around your house. But like, school's over here, your friend's house is over here, work's over here, shopping's over here. Every time you go somewhere, you have to be within a 2-mile radius of your house. It's impossible not to be. And so again, it's just the increased odds. It doesn't say the accident always happens right here. Okay, give me 2 seconds, okay? Hold on 2 seconds, guys. Okay, hold on. Can you go back? Okay. Can you go come right back? Go come right back. Okay, sorry. I have a 4-year-old that has to go to the bathroom. Surely she can make it to the teacher's lounge and back, right? Okay, we'll see. If I get up in a minute, you know why. So anyways, here's your home. Here's the 2-mile radius, right? It doesn't say that it always has to happen right here, the 2-mile radius between your house and school. It doesn't say it could happen here, 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 here. Think of how big that circle is, for real. And it could happen at any point on any road. No, when you walk in there, the light will turn on. So anyways, that's a lot of different possibilities. That's a lot of different places. So where you think like, wow, that's a really specific place to have an accident. It's really not. There's a ton of different places. They just happen to be 2 miles within your house because, again, it's that increased time. You spend more time driving within the 2 miles around your house because sometimes you just drive 3, sometimes you drive 33, but you're always going to drive 2 miles around your house. Here's an illusionary correlation that I love. This is the one that blew my mind. So, okay. If I told you that you had the exact same odds of being dealt the hand on the left as you do the hand on the right, you would call me a liar. But the truth is, you have the exact same odds of being dealt either one of those hands. Now, if you're like me, you're looking at it, you're like, no way. I played cards 100 times. I always get hands like the one that's on the left. I never get a hand like the one, or no, I'm doing left and right backwards. I always get a hand like the one on the right. I never get anything like the one on the left. I've never got that. Was that like a royal flush or something? I've never got that. I've played cards 100 times and I always get that one. So there's no way, Miss Parnell, there's no way they're the same. Well, it's an illusionary correlation. If I told you you had the odds of being dealt a royal flush over a mixture of cards, absolutely you have more shot of getting random cards. Okay, did you wash your hands? Okay, 2 seconds, stand right there. We're gonna go wash our hands. So if I told you that, well, here, let me keep talking before I pull it up. I keep getting like distracted by her, sorry. So if I told you that you have a better chance of getting dealt random cards over a royal flush, absolutely, because we all get random cards all the time, sometimes. But this is an illusionary correlation because this is actually a pretty specific question. The odds that I would deal you right now, if I had a deck of cards, that, and that in order, is the exact same as that I would pull over a 9 of spades, followed by a 3 of diamonds, followed by, see how I'm being specific here? A 5 of clubs, an 8 of clubs, a 6 of hearts. Like the odds that I could do these numbers in these suits in this order is just as much that I could do these numbers in these suits in this order. But people don't think about it like that. They look at it and see randomness and what you want. And they're like, no, there's way more shot. So that would be like an illusionary correlation. So that kind of explains it. I'll be right back.
my desk.
You guys ever notice I don't get interrupted this much during our normal class? Because I never have the 4-year-old. She's the one who interrupts. So anyway, so you see you got this. Like I said, the odds are 1 in 2.5 million, which is pretty crazy that I could do that. 1 in that and 2.5 million right now. So needless to say, if I had a deck of cards, I'm probably not going to do it. You think the hand on the right, you think you get the hand on the right more because it looks random, and you've gotten plenty of random sets, but to get that exact hand, those exact cards, those exact numbers, and those exact suits in that exact order is not random at all. And it's the same as if you wanted that. Does that kind of make sense? Okay. So that's like an example of a illusionary correlation. Yeah, here's my memes. Yes, I'm late for work. Yes, I have a venti iced coffee in my hands, but we must remember that correlation does not always imply causation. Thanks for you. And then the other one does not simply imply causation from correlation. So write that down. I don't know what you did with the iPad. You gotta find it. Write that down up at the top. That's really important. Correlation does not mean it causes it. It just means there's a relationship. If you want to see the cause, you got to take it one step further and do the experiment, which is the next part of the notes. So although correlational research reveals a relationship, it does not explain the relationship. So correlational research reveals a relationship, shows you there's a relationship, a good one, a bad one, negative, strong, positive, strong, weak, not one at all, whatever. But it doesn't explain a thing. It doesn't tell you why. There's no cause. It simply suggests a possible cause, like homes are more dangerous, but it doesn't prove it. And then you would do an experiment, you would do research, you would prove it and come to find out it's not more dangerous. It's because you spend more time there. So for example, the length of a marriage positively correlates with hair loss, kind of like what we were talking about earlier with stuff. And so you would think, oh my gosh, that means marriage stresses you out so much it makes you lose your hair. Well, not exactly. To have a long marriage, generally you have to be older. And as we talked about earlier, increase in age, increase in hair loss. And so I think that's it. Is that it for correlation? Yeah, there's some practice stuff. All right, let me show you this video. Do the different screen share. We have to be real quiet while I play this video so they can hear it, okay? Well, you need to look around for the iPad. It's in here somewhere.
Hello everyone, welcome to this research methods tutorial.
Hold on guys, I'll start it over. I know it's not loud. Hold on. Let me get it to go full screen.
Hello everyone, welcome to this research methods tutorial about correlations. I'm sure you know all this by now, so if you do want to go over it again, then just pause the video here and have a read through. So let's talk about correlations. They're used to measure the relationship between two covariables. So we're looking at two things that might vary or change together. Remember, correlations do not have independent and dependent variables because we're not deliberately manipulating one thing and measuring another thing. It's just two measurements that may or may not change with each other. So we could have a positive correlation where one variable increases and the other variable also increases. So as one gets higher, the other gets higher as well. So positive correlation looks like this. Or a negative correlation. So as one variable increases, the other variable decreases or gets lower. There can also be no correlation at all. You also need to know about what's called a correlation coefficient, and this is the result of a statistical test which will tell you the strength of a relationship between two variables. So whether there's a very strong relationship or a very weak relationship or no relationship at all. So the coefficients are on a scale. So the scale goes from -1 through to 0 and through to +1. If the correlation coefficient is 0 or close to 0, it means that there's either no correlation or a very, very weak correlation, a very weak relationship between those. The closer to 1 on either end, the stronger the relationship, and the minus or the plus sign tells us if that's a negative relationship or a positive relationship. So, for example, -8 is a very strong negative correlation. -3 is a weak negative correlation because it's closer to 0, which means there's 0 correlation. You won't have to calculate it in the exam, but you may be given a correlation coefficient and asked what it means, or asked to sketch it on a graph. So let's look at some of these strengths and weaknesses of using correlational studies. Correlations are good because the correlation coefficient gives us some information about the extent of a relationship. So it can say exactly how weak or how strong a relationship is, and that's quite useful information to know. They're also very good to use if it would be unethical or impractical to actually manipulate variables in an experiment. For example, if we wanted to see how well people concentrate depending on how much sleep they've had, it would be a little bit unethical to keep people awake all night or to let them only have 1 hour sleep or 2 hours sleep a night. But we could just measure how much sleep they'd had and find a way of testing their concentration and correlate those two variables. One of the biggest weaknesses of correlation is that we cannot infer cause and effect. We can't say that one variable is causing the change in another variable because there might be unknown variables that link the two, or there might just not be a causal relationship. For example, we could look at this positive correlation between the reported number of shark attacks in a week and the number of ice cream sales in a week, for example. It would be silly to say that shark attacks cause people to buy more ice creams, or buying ice creams causes more shark attacks. That would be silly. The variable that might link those is the sun. If it's a sunny day, people might go swimming more, so there's more opportunities for shark attacks, and they're also more likely to buy ice creams. So we can't say that there's a cause and effect relationship between the two variables. Think about something like height and shoe size. Shoe size doesn't cause a change in height. So let's have a look at some scatter graphs which show correlations. Notice that on my graph, I have a title, relationship between hours spent studying per week and test performance. Really, really important, even if you're asked just to sketch a graph, that you include a title. It's also important that you label your axes. So here, we've got the number of hours spent studying per week and the marks on a test out of 12. Otherwise, it's just meaningless data. Each of these data points represents 2 pieces of information from each participant. So this participant studied for 5 hours and scored 2 out of 12 on the test. This is an example of a strong positive correlation because we can see the longer somebody studies for, the higher their mark on the test. This is an example of a negative correlation. Again, it has a title and I've labelled the axes. So here we've got the number of hours spent watching TV per week, note 12, and marks on a test. So we can see the more hours of TV somebody watches in a week, the lower their test score, presumably because they're watching TV and not studying. And here we have an example of no correlation whatsoever. There's no relationship between these two things. So obviously the size of your TV will have no impact on the marks that you get out of a test. There's no relationship here at all. And that's all, folks. Thanks very much, and I'll see you again soon.
Hopefully you could hear that. I didn't realize how quiet it was, but hopefully you could hear that. If not, it's in the PowerPoint and you can go back and watch it on your own. Do a different type of screen share now. So here's some examples, some more examples. Low self-esteem could cause depression. Depression could cause low self-esteem. But there are distressing events that could happen in someone's life. There's some biological predispositions of like brain chemicals in their head, and they could cause low self-esteem and or depression. So you can't say, oh, because someone has low self-esteem, it's because of the depression. Or you can't say because someone has depression, it's because they had low self-esteem. Even though there may be a relationship, that's why it shows you a correlation shows a relationship. It doesn't show you the causation. You'd have to do more research to figure out the causation. The causation could be something like brain chemicals, something totally different you weren't even looking at or considering. We'll stop right there. Do the practice slides on your own. Yeah, there's answers too. So when you get done right now, just go straight into them and do them real fast, okay? So there's kind of 3 long questions about research. Read the following correlations and answer it. See if you can come up with an answer. 1, 2, and 3. And then when you go to the next slide, it tells you some answers. So there you go. You don't get a grade for this or anything like that. It's just kind of a little practice. You can write it in your notes. You can write it on scrap paper, whatever you want. But when I say bye to you right now, go do those 3 practice questions. And then you'll be done with correlations. We'll get into experiments. And I will let you know when you come to class next week more of an outline for when I think we're going to get done. Because we still have to go through experiments and ethics, and then we have to go through all the statistical stuff. So we still have a while. Unit 1's pretty big. So yeah. So any questions? I'll stop the recording.